In the other videos in this general compliance training, we focused on the retention approach for stormwater. In this video, we're going to focus on the detention requirements, which are outlined in Chapter 2 and Appendix I of the Stormwater Management. So the detention or the quantity control requirements are such that the 2-year storm peak discharge must be controlled to pre-development conditions. So conditions that were on the site before anything was built. The 15-year storm must be controlled to, the peak discharge must be controlled to pre-project conditions. So considering the existing conditions on the site, the 15-year storm in the proposed state must be controlled down to the pre-project conditions. This can be achieved through a number of different approaches. So underground storage can be added. We talked about that in another video. There are a number of different underground storage structures that can be used. Above ground storage can also be added to provide some temporary detention of stormwater runoff. You can also increase the size of the stormwater BMPs that are on site. So increasing the ponding depth of a bioretention, for example, can get you some additional storage. Even if it's in excess of what the retention value is granted for that, that storage in the BMP also can add towards this detention requirement. There are some exceptions to the 2-year post-development peak discharge requirements. They does not apply when the site discharges flow directly to or through one of these main stem of the tidal Potomac or Anacostia rivers, the Washington Channel, or the Chesapeake and Ohio Canal. I can show this on a map here. This is called the tidal MS4. So if your site is in the tidal MS4, it discharges directly to the Potomac or the Anacostia or the C&O Canal. And these areas may be exempt from the 2-year detention requirements. So you'll want to consider that when looking at your site. The goal of stormwater detention is to reduce peak flow rates. As you can see in the chart, the dark green plot has a high peak flow rate, which is a common impact of urbanization, and that high flow rate carries with it a lot of energy that can degrade receiving streams. We want to lower this peak and delay its timing by adding detention storage. In DC, a reduced curve number method is used to check if the proposed conditions and BMP storage adequately reduce peak flow rates to the relevant, that is the 2-year or the 15-year peak discharge. The first step in this method is calculating the curve number based on proposed land covers. There's a site runoff volume associated with this curve number. There's also storage achieved from the BMPs that are being proposed. The BMP storage is subtracted from the site runoff volume to obtain a reduced site runoff volume. This reduced site runoff volume is associated with a reduced curve number, which is then compared against the required curve numbers for the 2-year pre-development condition and the 15-year pre-project condition. So let's look at an example of that. So for the pre-project and pre-development conditions here for a site, you can see there's 2 site drainage areas, SDA1 and SDA2 on this site. The pre-development curve number is always 70. All right, so that's the pre-development condition before anything was built on this site. Whereas the pre-project condition, it varies, depends on what's actually currently on the site in the existing conditions when this project is under consideration. So for SDA1, you can see there is a certain amount of impervious cover with a curve number of 98 and a certain number of square feet of compacted cover with a curve number of 74. And the same thing for SDA2, you have this pre-development, the curve number is just 70, but the pre-project, it's going to be the composite of the impervious cover at the curve number of 98 and the compacted cover at curve number of 74. So this composite for the pre-project in SDA1 is a curve number of 92, and then in SDA2, there's a curve number of 88 for the pre-project condition. The post-project condition, this is without the BMPs. The post-project, there is a impervious cover proposed and a compacted cover proposed. So the post-project curve number is the composite of those areas and curve numbers, and it's 93 and 89 for SDA 1 and 2 respectively. So let's look at that together with the BMPs. So in site drainage area 1, there is a proposed one BMP or multiple BMPs that achieve a total of 1,800 cubic feet of storage. So this isn't the retention value, this is the storage value. But that storage is then subtracted from the volume that's associated with this 93 curve number, right? And this is done in the back end of the surface and groundwater system. You don't have to make these calculations. You just have to have your areas and your volumes correct. So the reduced post-project curve number for the 2-year storm is 76 and 80 for the 15-year storm. That's after accounting for this 1,800 cubic feet of BMP storage. In site drainage area 2, the post-project curve number was 89. So you're then going to subtract the 2,200 cubic feet of BMP storage from the volume associated with that curve number of 89, and then turn that into the reduced post-project curve number of 68 for the 2-year and 75 for the 15-year storm. So summarizing that in a table, you can see that the 2-year pre-development curve number for site drainage area 1 and site drainage area 2 and the site overall was 70, right? The 2-year post-project reduced curve number, this is after accounting for the BMP storage, that's what we showed just on the previous slide, is 76, 68, and then overall it's 72. So you can see, because site drainage area 1 has such a high post-project reduced curve number relative to the pre-development condition, you end up with this 72 for the total site that's greater than the required curve number of 70. So additional detention is required for the 2-year storm. For the 15-year storm, this is the situation that we often see. The existing conditions here are so much impervious area that the reduced curve number for the 15-year, based on the same BMP storage that we had, it gets us much lower, right? It gets us lower down below the required 15-year pre-project curve numbers. So overall, you have a 15-year post-development reduced curve number of 77, which is lower than the required 15-year pre-project curve number of 90. So no additional detention is required based on the 15-year storm, but based on the 2-year storm, there is some additional detention required. The hydrologic methods that can be used to demonstrate that this additional detention that's going to be provided, so if you're doing an underground or an above ground storage tank, is spelled out in Appendix I. So there are a number of different methods that are accepted to demonstrate that the peak flow in the proposed state is going to be reduced below the peak flow, in this case in the 2-year storm. So the urban hydrology for small watersheds, TR55, storage indication routing, and a number of other computer models are out there that can be used. TR55 and SWIM are preferred because of the ability to account for detention benefits from the BMPs. Rational method is not recommended for detention because it can't easily account for those BMP benefits.